Hi everyone, so today we are going to discuss about the problem to some problem. So let's see what the problem says. So you are given an array of size n and you are given a number x, so you have to check whether there exist two numbers in that array such that when those two numbers are added they get equal to the given number x. So like if you have this array and in which you have two such numbers such that when they are added they are equal to number x, so that is what you need to check. So in an you can get two types of questions. One where you have to just return true or false, whether two numbers exist or not, you have to return true or false. Other variety of this question could be where you have to return the index of those two numbers if they exist, and if they don't exist then you have to return -1, and if there are multiple pair then you can just return any of the pair. There could be one more variety which I have not written here, which is instead of the index of the number you have to return the number. So in multiple form variations can be there of this question. So let's see just two examples for this. So you have this array 6 2 minus 2 4 and you have given x is equals to 6. You need to check whether there exist two numbers such that when they are added they are equal to 6 or not. So if you see here we have one pair called where 2 and 4 are there, and when they are added they can be equal to 6, right? Similarly we have one more pair 1,5 which is equal to 6 when it is added. So if the variety is of type 1 you can just simply return 1, and if the variety of type 2 then you can simply return 1,3, or you can return 5,6 as well if the index are wanted, and if you are asked to return this number then you can simply return 2 or 4, or you can return 1,5, right? So if you see second example, then there does not exist any pair which is equal to 6, right? So in case 1 you can simply return no, and in case 2 you can simply return -1, right? So this is about the problem. Let's see if we have any, what are the ways or how we can code this problem. So we will start with the very simplest approach, which is the brute force approach. What we will do here is we will run two loops, right? So for 6 we will check the complete array and we will see if there exists any number when that number is added to 6 it forms the number 6. Similarly we will check for -2 and we will check the rest of the array if there exists any number which is equals to 6. If it exists we will simply return and end the loop, and if it doesn't exist then we will check for the next element. So it is very simple, right? Very simple. So let's see how we will code it. So if you see you are given in the input you are given an array which is of the vector type. So considering we are coding right now in C++, then you have the size of the array which is denoted by n, and then you have the number x. Okay, so let's take two variable int I and int j to iterate over the array, and then let's see, let's store for I is equals to 0 and we'll code it for I is less than n, I plus plus, then we will go from for j is equals to I plus 1, j is less than n, j plus plus, and then we will check if array at I plus array at j double is equals to x, and if it is equals to x then we will return what? We will return yes, and if it doesn't find we'll still run the complete loop and we'll just return no, right? Sorry, instead of yes and no, of course we have to return true and false, true, and we have to return here false, right? So if you see what is the time complexity, and there might be one question that you guys can ask, that why we have started from the next index as of I, why not from 0? So if you see you can do that also, but although the complexity would be same, order n square, but it is using some extra iterations, because if you check you are when you go from here to here for 6 you will check -2, right? But when you go from -2, when you've already checked 6 with -2, why do you need to check -2 with 6? You have already checked in the previous iteration, so why to waste the iterations? Okay, so compared to that, this is much better. So if you see what is the time complexity, so time complexity of this approach is order n square, and we have not taken any extra space, or space complexity is order 1 of this approach. Now what if you were asked about the case 2, where you have to return the indices, right? So instead of boolean, that time this time our return type would be pair, because we have to return 2 indices, right? And here instead of true, we have to return what? We have to return I and j, the pair, right? And if it doesn't exist, we have to return what? By -1 and -1. That's it. Code would be same, complexity would be same, only these things would change. That's it. Okay, so now let's see what are the other approaches to solve the same problem with less complexity. Okay, so other complexity is approach would be to use the loop efficiently. Okay, so what we could do is just sort the array. Initially just sort the array. So if you see 0 1 2 3 4 5 6 and 7, you have already sorted the array. So now you know that the numbers are present in the increasing order. Okay, so what we can do is in the earlier approach, what we did, we kept one pointer here and the other pointer to in the next point to it. But what we'll do here, we will keep one pointer here and we'll keep one pointer at the right side. So you have to keep one pointer to the leftmost side and another pointer to the rightmost side, and then you have to check the sum of those two numbers. So if the sum of those two numbers is greater than the number that is desired, that means you're going beyond the wanted limit, so you have to lower down it. You have to lower it down. So how can you lower it down? Only when you move to the left side. So the approach is very simple. Just start. What would be the approach? Start from leftmost side and rightmost side. Okay, leftmost side and rightmost side. Okay, then take the sum of those two numbers. Take sum of those two numbers. If sum is greater than x, that means you know that you have exceeded the desired number. That means you have to lower down one number. How can you lower down the sum? Only if you decrease the right pointer, right? So what you need to do, you need to move the right pointer to one side left, right? And if sum is less than x, that means you have to move the left pointer to right. And if sum is equals to x, that means you have to just simply return. That's it. Okay, similarly if you check with this approach, so if we see this -2 plus 9, what is it? -2 plus 9 is 7. 7 is, if you keep one pointer here and one pointer here, -7 is greater than 6. So what you need to do, you need to come to this side, right? Now if you see -2 plus 6, -2 plus 6 is 4. 4 is less than 6. So what you need to do, you need to move left pointer to the right. Now if you see 1 plus 6 is still 7, that is again greater than 6. What you need to do, you need to move to the left. Again if you check 1 plus 5 is 6. That is what we wanted as well. So you can return these two numbers, right? This approach is very simple. Now let's see how to code it. Again I would take int I and j. Okay, what I'll do, I will keep 0 to the I to the beginning and j to the rightmost side of my array. Okay, now what I'll do, I have to make sure that my I remains like what will be the stopping condition, what will be the terminating condition of the loop. That's it. The terminating condition of the loop would be that I should always be to the left of j. It should not cross the j, otherwise you will again waste the iterations, because you will be checking something that you've already checked. Okay, so while I is less than j, you have to check if array at I plus array at j, if it is double equals to x. If it is equals to x, then you can simply return what? You can simply return yes. Oh, wait, I have missed one very crucial step, that is to the sort, that is sort the array. This loop, this code won't make any sense if you don't sort the array, right? So you have to sort the array, array dot begin and array dot end. So now you have the sorted array. So this is the step that we have missed, right? Okay, now you have to check else if it is equal, then you have to return that. But if array at I plus array at j, if it is greater than x, what you need to do? You need to decrement the right pointer. Again, else what you need to do? You need to just increment the right pointer. Now if your loop ends and you don't return yes, that means there does not exist that number, so you can simply return no. So if you see what is the time complexity of this approach, so time complexity of this approach is order n. Okay, let me do it from here. Okay, so time complexity of it, this would be order n log n, that is for sorting the array. You have sorted the array, then you're running the loop, which in the worst case could go to the entire array. You might be because your array could look like this. See, 0 0 0 0 0 and then 1 and 5, then it could be -1 -1 -1 -1, right? So in the worst case you would be coming here, you have iterated this also and you have iterated this also. So in the worst case you might end up iterating the complete array. So it could be the time complexity would be order n log n plus n, which would be order n log n only. Okay, because we would be taking the highest one and we have not taken any extra space, so space complexity is order 1. Okay, now let's see what is the approach for case 2 when you have to return the pair. So for return the indices, I won't say that this approach would be a very nice approach. Reason being, if you have to return the indices, then you need to store an index as well. Which means space complexity would increase, right? You need to store the index to return the index. You can't simply return, because when you sort the array, index would definitely lose up, right? When you have sorted this array, -2 is now at index 0, but initially -2 was at index 1, so you have lost your index. So you need to take the space to store that index as well. So what you can do is you can take one extra array, or you can take vector of pair you can take, and you can again sort that, and when you just return, you can just return the second element of those pair, because that would be the indices, and here you have to just return -1, -1. So in that case, again the time complexity would be same, order n log n, but space complexity would increase up to order n. But since I talked about case 3 also, where you could be just asked to return, the number, not the indices. So this one was for the case 2, this one was for the case 1, right? If you are asked just about the numbers, then you, instead of storing something extra, because now you don't need to store anything extra, you don't need indexes. So what you can do, you can just return array I and array at j, right? Here you can directly return -1. So if you are asked about case 3, then you don't need any extra space, then only the time complexity would be order n log n, and space complexity would still be order n. Okay, so if that is the case where you have to return the indices, so you see that the time complexity is order n log n and space complexity is order n. Let's see if we have any approach where we could minimize the time complexity as well, right? Okay, so let's see one more approach, which is the approach 3. So approach 3, I'll be using one data structure, that is the hash, where I will be using key as the my elements. I will use elements as my keys, and I will use value. For value I will store the index. So for example, I will store, if this is my hash, how I will store like 6 is present on element on index 0, minus 2 is present on index 1, 2 is present on index 2, 4 is present on index 3, and so on. Okay, so this is how I'm going to use. Now if you see, if a plus b is equals to x, that is what we need. So if I'm searching for 6, so if I'm searching for 6 and my x is also 6 and my x is also 6 and I'm currently at 6, what do I need to search in my array? Okay, like if x is 6, if my element is 6, what do I need to search? I need to search if 0 is present or not, right? If minus 2 is there, what should I add in minus 2 that it becomes 6? So what should I do? I should just do 6 and 6 minus 2, that is 8. I should add 8 in minus 2 so that it becomes 6, right? So that is how we'll be checking. For 2 I would be checking whether 4 is there or not, right? So this is how we will check. For 4 I will check whether 2 is present in the hash or not. For 1 I will check whether 5 is present in the hash. So I will check something that when added to that number becomes my x, right? Simply, if a plus b is equals to x, I have to check x minus b. Okay, you need to find that only. It is very simple. Just if you don't get it, just pause this video for a while and try to understand what I am saying. See, if 5 is there, what should you add in 5 that it becomes 6? The smallest number, it should be 1, right? 1, if you add it, you should get, or whatever number you should add. Like if 6 minus 5 I do, what should you add? 1. If you have to check whether 1 is there in that array or not. Okay, so let's see if you have to return boolean and your function is to sum. Let's see, vector, this is your function, vector int array int n and int, you have int x, right? So what I will take a hash map, unordered map. I will declare it of type int comma int. I will name it as hash. Okay, and then I will just use my one variable int I to iterate over the array. Then let's do for I don't need to sort the array this time, so that complexity is not wasted. That complexity is not needed now. For I is equals to 0, I is less than n, I plus plus. So the approach that I'm going to use now in this is very simple. First of all, I will check whether x minus a is present in hash or not. X minus a is present in hash or not. Okay, for example, if 6 is there, so you have to check if 6 minus 6, 0 is present in hash or not. That's how you will get the pair, right? If my array element is 6, if my x is 6, then you should search for 0 only, because 6 minus 6 will only make up 0, right? So I will check whether this is present in the array or not. If yes, I will return yes and terminate the loop. But if I don't get it, if no, I will store the element with index in hash. Okay, because right now it might not be present, but maybe in future you might need that element, right? So for I is equals to 0, I is less than n, I plus plus, I would check if hash dot find x minus array at I double is not is equals to hash at end. That means is not is equals to hash at end, hash dot end. I hope you are aware of I hope you are aware of this unordered map data structure and also how to use it. Okay, Then you have to check if it is not is equal to, as we wrote, that whether x minus is present in hash or not. If yes, then you have to return yes and terminate the loop. So it is not is equal to hash dot end, that means that it is present in the loop. That means it is present in the loop. So what you need to do is you just need to return yes. That's it. You just need to return yes. But let's say it is not present in the hash. So what you need to do is you just need to store that hash at array at I double is equals to I. Okay, and in the end also, if after loop also you don't get anything, again I am writing it yes, return true. You have to return false. Okay, did I in the previous also I wrote true and false? Okay, please forgive me for this. I'm using yes and no instead of true and false. Okay, so let's dry run it on our array. So we have this array. Again, let me write it here. 6 minus 2 2 1 4 1 4 1 3 5 and 9. Okay, and given my x is 6. So we have created a hash, and for I is equals to 0, I is less than n, I have to check whether if hash x minus array at I is present in my hash or not. So array at 0 is what? Is 6. So I have to check if 6 minus 6 is present in my hash or not. But currently my hash is empty, so this condition got false. So what I need to do, I need to store it. So I stored 6 and 0 in my hash. Okay, then I checked for minus 2. So what I need to do is 6 minus 2. So what it is equals to hash 8. 8 is there in my hash table? No. So it would be what I have to store, minus 2 and 1 is stored in my hash. Then again for 2, 4 is not there, so I have stored 2. Then 4 it is 6 minus 2. 6 minus 4 is 2. But 2 is present in my hash. See, this time 2 is present in my hash. So what I need to do, I will just return true and terminate the loop. Means after returning, the loop will automatically get terminated, right? So the time complexity of this, it is this much simple. So time complexity is again order n, space complexity is again order n. Because why? Because we have used a data structure called hash, and since we have used unordered map, so it won't take that much time in searching. So you can say that the time complexity is order n. Now what if you were given you have to return the pair, like the variety, the second type of this question that we discussed in the beginning of this video. So this complexity is for case 1. So for case 2, what you need to do is, just instead of returning true, what you need to do is you need to return the pair, you need to return the indices. So what you need to do is you need to return hash of x minus array at I, because that would be storing my number, and you have to return the index of, and you have to return I, because that is my current index. Okay, and here instead of returning false, you would have to return minus 1 comma minus 1. Okay, now you can ask me that why have we written this one in the beginning, है ना? Why we have written this one in the beginning? So if the element is already available in the hash, that means it came before the element that you are currently on, right? If something is already available in hash, that means its index was earlier, it came before than the current element. So it is just, I have just used it because there might be one more variety of this question where you would be asked to return the smaller index first. Okay, so for example, if 2 and 4 are present on 5 and 6 index, you would be asked to return 5,6, not 6,5. So that is why I have written like this. There is no other meaning of using it. So in case 2 also, time complexity and space complexity is still the same. Okay, so we have seen 3 approaches. in first approach the time complexity was order n square, complexity was space complexity was order 1. In another, time complexity was order n log n, and for return the indexes space complexity would be order n, and in third case time complexity and space complexity was order n. Okay.